Cool. As Sam said, thank you for having me. And my name is Tim Strazzere, and I'll be doing identifying and evading Android protections today. So just a quick overview of who I am. I go by Diff because one of the first companies I worked at, there were many people named Tim. I know that's kind of a lame story, but that's basically where we started with. So currently I'm over at Cloudflare as a security engineer. I do both product security and I do threat intelligence research. And previously I had been at Sentinel-1 doing research, and I've also worked at Lookout with Emily and Ben. I enjoy looking at obfuscation, fuzzing things, and unpacking things. Maybe that makes me a masochist, I'm not really sure. I do enjoy making hot sauce because I know I'm a masochist. And you can follow me at on Twitter at Tim Straz, or check out my GitHub where I post lots of tutorials and different open source tools to aid in reverse engineering both malware and good products. So why is evaded in the title? It seemed like a weird thing for me to put in the title, but basically this revolves around how I approach bug bounties and how I do it from like a return on my investment perspective. So bug bounties are just essentially, to me, an exercise in sunk fallacy, which if you Google that, if you look it up, if you are an economist, you would know. Basically, people make rational decisions, or we think we do, on the future value of objects based on how much we've already invested. So if I've been working on a hard problem for a week, I'm more likely to say, okay, I want to keep working on this because I've just put so much effort into it. The truth of it is that's actually an emotion inside of us thinking, well, I don't want to waste my time and I must be really close because I spent a lot of time. And that's essentially how I try and approach bug bounties. I see flashing from Zoom. Let me see what is going on.
It's probably just questions or something.
Okay. If my video cuts out or anything, Sam, can you just step in and let me know so I don't have to drop out of the full screen? So essentially, what I'd like to call this sunk cost fallacy is don't do work for free. Avoid NDA traps and other large obstacles. The way I try and approach a bug bounty essentially starts with, what is my goal? I think before you start hunting for bugs, you should say, I have a goal and it's to, learn something new. I want to find a high priority bug because I've never gotten one. Or maybe I want to find 3 bugs because I'm doing this in a crunch hour before I go out or something like that. Or as I'm working on this bug bounty, I want to make $40 an hour. And this is just so that you can set a target. You don't have to do this. You don't have to, make it a financial, just make a goal. And then what happens is, go and look at different targets, skim the bounty rules, skim the scope, skim the payouts. If you're targeting for $40 an hour and they don't actually give you money, they just give you bug bounty points, why bother? That's not your goal. Do they have a good track record? Are they paying out bounties? Do they pay out bounties and they're very high? If you look at some companies, they only award $500 bugs, or they only award $100 bugs. Some of them only give out a t-shirt. So just make sure it matches up with your goal. Also, I tend to stay in private bug bounties. Those usually require an NDA, and these can be tricky. Essentially, that means you might be looking at newer products. You're not allowed to talk about it. So if your goal is to blog about something and do research publicly, you probably want to avoid those kind of things. So after this, like I said, you have your goal, you skim the rules and the targets. Do they fit your goal? If not, don't bother doing it. And then just start hunting for an hour. Be honest with yourself. Stop after that hour. Say, am I tracking toward my goal? If I haven't gotten any bugs yet and I'm saying that I need to, make $40 an hour while doing this, you're guys basically going to be able to look at that payment structure again and see, all right, if I work 1 more hour on this and I don't find a bug, then I'm never going to hit that goal. Or maybe you can, but just be honest with yourself. And this is a way to see, like, how am I doing? Am I doing better? So the next step we just do is, are we still, again, on track for those goals? If we're not, stop. It's not admitting failure. It's just saying, you didn't reach your target right now. If you are on track for your goals, keep going. And hopefully what happens is, after a while, you've trained and honed your skills and you're getting to a fast enough point that essentially you should be collecting money or collecting bugs or writing blog posts, whatever your goal was. But essentially, if you follow this, you kind of know internally to yourself, where am I standing at? Should I be anticipating that I should be able to find a bunch of bugs in the first hour? Or, this is a great way to track your progression as you do 10 different bug bounties. Oh, I used to never actually get bugs in the first hour. Now I'm up to 3 or 4. So it's just a good way that, and this is again, how I approach it, trying to avoid that sunk fallacy where you just spend so much time just looking at certain applications and you never find anything. Again, this kind of just sums it up. If you shoot targets, basically what's going to happen is, some people have high accuracy, high precision. That's great. But honestly, looking at the different ways that people shoot or attack these targets, maybe they just have specific goals in mind. And, low accuracy, high precision, that might mean you hit, some P3 bugs because you really wanted P1 bugs. And this just lets you kind of track that and see how you actually want to move forward in your bug bounty attempts. So applying this to mobile bounties, how do you do this? Again, this is honestly my approach. I do it for lots of private bug bounties. I sometimes do this for public ones, but the reason I'm saying I do it for private ones is usually those that tend to be new, fresh targets that people haven't already cleaned up all low-hanging fruit. I tend to go through and do quick passes for low-hanging fruit, and then I'll go back for harder ones if I'm still able to meet my goals. So some things that really just take time and you want to avoid while doing a bug bounty, especially if you're going for speed, it's basically going to be, avoid packers and new obfuscation that you've never seen. These are great things to come across, but you don't want to be spending your time, which is essentially, the value of your money, but while trying to just learn how to unpack things that are new. And often these packers are commercial things that people have bought, and so it's not even their actual code. They might not pay out on this. You also want to try and avoid having to trip over anti-root measures or anti-emulator code. So you're going to want to try and pay that value up front and have a system already set up, much like what Ben was describing, so that you can avoid these things. You don't have to deal with them, because most companies are not going to pay out when you say, I was able to bypass your anti-root detection. But you will probably need to bypass that to find actual bugs. There's other ones that are requiring special environments, and this might happen if you're doing IoT or potentially, hacking specific tablets that are used for point-of-sale systems, something like that. So actually, a friend and myself, we ended up creating an application called APK ID, AppKid, if you want to shorten it. And this was basically attempting to be a clone of PE ID. And what we've done is we've actually created a bunch of rules for known packers and known obfuscation methods. And we've actually had a bunch of people from the open source community actually submit more detection mechanisms for us. So essentially what you can do is if you find a new target, you can install this. If you go to the actual GitHub page, Red Naga is the group that we both work with. And essentially you're going to be able to clone this or just do a pip install. And this will be able to run on either your Windows machine, your Linux machine, and your OS X machine. And basically, you're going to download a target, run this on it, see what the output is. Essentially, this is an example. I downloaded something. It was an application. I haven't even opened it yet. Granted, this is a little stage, so I did know it was going to pop a detection. But essentially, what we're having right now is APK ID detected on the APK that the packer was coning. It's also given us a few hints of, what the compiler may have been, what the manipulator maybe was. And this might be interesting to you, if you've come up against a lot of targets. It kind of helps you profile the developer's environment. This might just be useless information to you, but it might end up being a little useful if you do a little research into it. We're also seeing the anti-VM flags, because we do see that the application is calling out to these specific checks. So what happens is these checks sometimes are used to basically look for a VM, look for a mocked out device, so that they can say like, oh, I don't want to run on this, and let's bomb out of it. So again, it pointed out Coney, so that's great. That means someone has already known what Coney is at least. Doesn't mean that we actually have all the steps to unpack it, but it does say that like this is a known thing, so you're not at least dealing with some homebrew stuff. And then if you dig into the source, we see all these ooey gooey center basically saying like, oh, there's some decryption keys in here, there's a library, and there's also an encrypted JS. So if you don't know what Coney is, we'll go into that in a minute, but this was essentially what the detection that fired on that application, which was previously unknown, and this is how it detected that it was Coney. Also, just as a side note, if you do think you're running into commercial packers or potentially some weird protection scheme, and it is not detected by APK ID, I urge you to please submit an issue. We've had tons of people say, I don't even know what this is, but I've seen it on a lot of applications. And then they just give us a couple hashes. We'll go do some research and we'll help you try and identify it. Other things are, we do have a bunch of people who basically come say, here's an issue, here's a pull request. This is a new, let's say, Chinese packer. Here's how you unpack it. So if you dig into that repo, you're actually going to find a lot of interesting, useful information on how to unpack or sometimes defeat these obfuscators. Now back to the Coney sample, doing a little bit of Oppo research. Maybe a Russian lawyer will give you this information. Maybe they won't. I'm not really sure. But essentially what we're looking at is it's a quote unquote packer with a JavaScript VM. So essentially it's an SDK that a company is providing to their end users, allowing them to kind of do, it looked like the Google App Genius stuff where you're able to like drag and drop some different things and write in some pseudocode and it compiles it down. The SDK actually allows you to output iOS applications and Android applications while only writing JavaScript. This is kind of a cool system to attack. I'll go into more details later on why this could be monetarily very beneficial to us. But just a quick win right away is someone's writing one set of code that's going to be running on iOS and Android. Now, do they have an iOS and an Android application? If you find a bug in one of those, it's probably going to be a bug in the other one. And often these are not marked as duplicates. You just need to present them as a different attack approach in either one of those environments. So there's a lot of low-hanging fruit. And essentially what I want to say is, as we're trying to go fast, we don't want to look at the Coney VM. We don't want to look at anything that Coney has written because that's not actually going to be the developer's code. So they might not pay out on anything except for the JavaScript code. So we need to get to that as fast as possible. So, we have it detecting. Now we're Googling around because, we're lazy and we don't want to just, figure out this stuff. So basically we're like, oh, sweet. Someone did a Black Hat EU in London. And it looks like they're talking about how do we, deconstruct these things. It's from 2015. We're in 2017 now. I don't know if it's valid. Maybe it is. Some people are really lazy and just never change their code. So we dig into this, and this was a nice Black Hat presentation. I believe it was from the guys over at NCC, and they were presenting in London. And it's interesting. Their approach is they started to reverse engineer everything, and they noticed that their SDK was giving these interesting flags, specifically the one at the bottom, encrypt zip files. Encryption is interesting, and we see what it's doing. Essentially, they dug into it, and the SDK used to ship out binaries to every user, which when they were compiling, they would basically load all their JavaScript, they would compile it down, minimify it, excuse me, and then they would load it into Coney load file with a couple different hard-coded values that were getting passed in. And what it turned out being was, they're passing in an IV, an encryption key, and they're passing in the actual JavaScript, and they're just using this file to actually encrypt all that JavaScript on the user's machine. So the old method of breaking, it's really not that impressive, but it's a great find by these guys. Essentially, they took the Coney load file executable, and they just patched one byte. And instead of telling it to encrypt things, they told it to decrypt. So, okay, easy enough. If you find an application that has old Coney, you could use this method if you can find Coney load file. Apparently, developers can also read and can also Google things. So when you call them out in public settings, they tend to get angry. And then they tend to try and, block things that you do, like make fun of them when you just patch one byte to defeat their protection. So it got fixed. And it's kind of like playing a game and getting punched right at the end, right after you win. Now your method no longer works. The SDK no longer ships with the encryption binaries. Essentially, they're doing all the compilation in the cloud, and then they ship the binary to the end user. So now we don't actually have any of the encryption binaries. We don't have any of the code that they're using on the actual developer's machine. But they fixed it, whatever. This is going to make it more interesting for us, hopefully. So what's the next step? It turns out that in the 2015 presentation, they basically had reverse engineered the encryption method. They basically talked about it in pseudocode, And if you dig into it now, it's pretty much exactly the same thing. They just changed a couple of the values around, but they're still pulling all the information from the same spot. I've documented this in a gist on my GitHub. It's really simple C code. Essentially, it looks like this pseudocode. They're taking a key that they've basically embedded into the shared library. They're taking another key that they've embedded into a shared library. They're running those through two different XOR methods with a couple different keys in there. Those are all based on each individual customer. And then they calculate that hash but after they do a SHA-256 on it. And then they pass in a static IV. And this is granted very easy to understand. It's pseudocode. But if you go to that gist, you will find all the actual code for decrypting this. All you need to do is find where those static keys are in the shared libraries. And it's pretty well, it's pretty well out in the open because they haven't actually stripped any of the binaries, and all the pointers are still there and they're still named. So you can see things like key for car, and all these kind of things. So looked like maybe Coney got angry because someone must have been saying, I can still get to the ooey gooey center, and they're still making lots of money on these things. And it seems like some of Coney's customers were probably saying, hey, like you told us you're gonna provide some protection, so we want you to actually, you know, protect our code. So what happened is I started seeing Coney binaries deployed using an ArcSan packer. So it's basically, you're gonna have two sets of packers. I'm not even sure if this is allowed by ArcSan policy, because this means that someone is distributing ArcSan binaries for individual customers. It would make sense to me if each one of those customers had to buy it from ArcSan, but you know, that's not my deal. I just don't want to deal with them. So essentially what we're having is we have like crazy, crazy fancy bear stuff. Not really. I mean, that bear doing like judo chops and everything down there in the bottom corner, that's badass, but it really isn't that bad. Not with reverse engineering this stuff. Right now, what we have is the dev's gonna write JavaScript. It's gonna be compiled by the Coney SDK, and it's wrapped with the SDK. So there's that normal encryption that is happening to the JavaScript zip, and it would be loaded by a shared library. And then it appears that they've loaded ArcSan, and they've applied the Dalvik and the shared lip obfuscation and flattening. And this actually makes it pretty decently hard to reverse engineer any of their native code or their Dalvik code. Most of the strings are going to be obfuscated. They're not going to be plain text. And these get shipped to the developers. And I've run across a few of these in bug bounties, and it's a double-edged sword. We want to go as fast as possible, and we don't want to do any of that research since we're not going to get paid for the research of unpacking. But what we could do, if you basically knew how to do this, they're making the barrier to entry for other bug hunters pretty high. So if you come across this binary and you knew how to unpack it, you're gonna have a great time because maybe nobody else has unpacked it yet, and you're gonna find all these low-hanging fruit bugs that can make you lots of money. So we're just gonna hack a little harder, and we're gonna get around that, that double protection with the ArcSan and the Coney SDK. What ends up being pretty interesting is ArcSan's doing a lot of the heavy lifting. ArcSan usually will detect emulators and rooted device, and so you're going to need an actual normal device. So a normal device is going to be something that's probably not rooted and doesn't have any of your special tools on it. But what's interesting is if you see in many of the Android application scopes, most people say, I don't care if you can make this debuggable. Also, if it's debuggable, I don't care about that. So they're not paying for that, which I find very interesting, because what happens is this is something that makes your application a lot easier to hack around with. So now I want to avoid using an emulator and a rooted device, and since I can turn the application into debuggable because ArcSan doesn't check it and neither does Coney, I'm basically going to re-sign the application and tell it to be debuggable. Now I can actually get a shell as that application ID, and I can attach a debugger to that application, and I'm not root, and I'm not on an emulator. So none of those actual anti-protections are going to flag me. So instead of sitting there and having to battle with, you know, oh, let me change my board name and I'm going to reboot my device, or let me, you know, hide my SU binary, you can just use a normal device and they don't care. And then the interesting part is you can also run an ADB, or excuse me, GDB in the Android shell, and you're going to be able to attach the process and dump memory if you want. Or you could just dump memory directly using DD. And the interesting part is most of these protectors don't protect the memory. So basically what we're going to do, and this one ended up being real easy, so I don't even need to explain much of it. But so the native code performs exactly the way it did before it was arcsand. So we're going to see a load to encrypted file, decrypt the file in memory, and then it frees the memory after it starts running it. Except Android doesn't always free memory right when you say free the memory. So the memory is still resident. They've lost their pointer, but it's still sitting there in space, and it's still sitting in that process's memory. So what can we do? We just go to the process, and then the PID number, memory. We can look at the maps, and we can see what's in there. And if you go and check out one of my other repositories, there's actually a script that will automate all this for you, where you're basically going to be looking for a memory segment that has been used by malloc and in an anonymous state, and search for a PK header. PK header will identify that it's a zip, and then you'll actually see the file name next to it. So what we ended up doing for this arcsand Coney protected application is we noticed that libc malloc is going to be the flag that we're going to look for in the proc PID memory. And essentially, this is the malloc memory that they were using. It used to be encrypted, and then they decrypted it in memory for us. And now that they're using it and running it, even though they've freed that memory, we're able to access that memory while the application's running. And again, since it's not checking that we're just attached to it, or it's not checking that the application is debuggable, we're allowed to do this, and it doesn't trigger any kind of the code in arcsand or Coney to detect us. So that one ends up being easy. Now, why did I specifically go over Coney? Coney was an interesting one to me because they're trying to attempt to have two separate layers of protection. Both of these things might take someone quite a lot of time to actually figure out, depending on where they're trying to attempt and hack those weak links. And Coney ends up being a really rich target for bug bounties because there's countless banks, financial institutions, large stores, insurance companies use this, airlines use this, and it's really, really large corporations who are going to pay out on small bug bounties, in my opinion. So what you can do is you can attack lots of different bug bounties using the same attack, the same approach, and if you automate a lot of this, you might be able to clean up some easy $100, $200, $300 bugs. I've done it a few times, and these companies still keep using it. And again, all their code is JavaScript. So you can abstract away all the knowledge of saying, well, I don't know Android, I don't know C, I don't know how to use IDA. Just use a regular text editor, get the JavaScript code, and look for logic flaws. So again, what's this lesson learned? Attack targets you have known solutions for. If your goal is for speed, don't sit there and try and unpack this new version of a packer that nobody's ever seen before. Probably tweet about it and say, I've never seen anyone complete this. Maybe someone's gonna rage a little bit and then do all the work for you. It might be interesting. But again, if you're going for speed, you're going for money, attack things that you know you can try and automate or that you know you have a solution for. A lot of companies that are using specific SDKs or protectors in their actual scope say, if you find a flaw in my application, but it's in a commercial product I bought, I'm not going to pay out on you. So again, if you're not going to get paid for attacking the SDK or attacking the protector that they've used, then why bother? You don't need to go to that. You just need to get to the ooey gooey center of that code. And then again, I think a good way to hone your bug bounty skills is do research on these protections in your free time. If you can build up an arsenal where you know how to unpack all the latest unpackers, this could be really interesting if you see any bug bounties pop up using these. And again, you might be able to get to the actual stuff beforehand, and everyone else is still trying to learn how to unpack that. And after you've unpacked it, you're going to get all these super duper easy bugs that nobody else can see yet because they can't get to their code. Also, keep your open source tools up to date. A lot of these tools I've mentioned so far, they are open sourced by myself and a few of my friends. I'd appreciate it if you find a way to unpack things, you should give back to the community. Also, what happens is the developers end up making it a little bit harder the next time, and it's a fun challenge that we can keep going by birding all their solutions. Other bug bounty TLDRs. Essentially, I explained at the beginning, I try and go for low-hanging fruit, and I try and automate all my low-hanging fruit. This is sort of a overview of my low-hanging fruit from 2017, which I've automated. And I've done a lot of these in private bounties and some public bounties. And just to go over some of the wins I got, I've donated pretty much all of this money directly. So this is not me hopefully trying to brag about money, but these are automated solutions, and all my automated solutions go to charity. So devs have included source code on very many occasions into their applications. Often it's packed or encrypted, and I'm not sure how it's getting there, but they pay money for you to say, you left your source code in here. I can see all your comments. Often there's very interesting internal only comments in those. I've seen multiple applications that contain their private keys. I got paid out on 2 of these. One of them, they made me crack the password, but it was relatively easy to crack. We also see dev credentials in dev environment credentials. And they're hard coding quality assurance usernames and passwords, or the developer ones. And sometimes those are the same passwords on the production devices. So if you point those out, you're gonna probably get some money. And again, these are easy things to search for. All you would need to do is unzip and look for something that looks like a .java file or something. We crypto and failed cert pinnings is in there a lot. Document changes and bugs in shared libraries. This one's really interesting to me because what we end up seeing is companies that will pay out for their SDK apps. Let's say they're using Coney and they say, okay, I'm using Coney. If you find a bug in it, I will pay you so that I will fix that bug. And there's other ones. There's many SDKs that people use. And essentially, it can sometimes be really fruitful that these are open source SDKs. If you go to their GitHub, you find a logic flaw in one of those. If you know different bug bounties that will pay for libraries they're using and have not written, you can often submit the same bug multiple times. So I think I had 6 instances of the same bug in an SDK, and I found 6 different companies that were using that SDK, and they all paid out about $250. And then there was another instance of 1 bug in an SDK, and 2 companies paid out for that. So these are really easy things that you can do super fast. So far, that's about $2,000 donated in 2017. Often, again, since I've automated all this is under 5 minutes of work. And so if we can basically, again, automate the unwrapping and the deobfuscation of applications, and then you can automate your low-hanging fruit searches, you basically are just going, okay, I want to do this, and let me click a few buttons. You sit back, go get a drink from the fridge, and then you can submit these bounties. It's a good high return on your investment. And again, this is what I've been doing, and I suggest other people do it. You're essentially just going to be racing against other developers and their automation sets at that point. And then just on the soapbox, I did mention all my automated bugs that I find, they get donated right away. I do hope that people listening care about, community and whatnot. And essentially, I would love if people were hacking for good. And if you're really good at finding, let's just say, cross-site scripting bugs, maybe you can do that and donate what you found, both in knowledge and in money. So if you can donate to any organization that you agree with, some kind of NPO, a lot of these bug bounties will match your donation. So if you found a $1,000 bug, they're going to let you donate $2,000 total. Not everyone sometimes wants to do something for someone else for free. So these also count as tax write-offs, which can help you in the long run for when you find really awesome bugs that are not automated and you weren't going to donate those. So you can kind of offset the two if that makes you feel better. And that's essentially all I had for today. These are some references and resources, both that I've done and some friends of mine have done. Again, APK ID, that's going to help you detect things a lot faster. We also did 2 talks about APK ID and how we were using it to both detect pirated and malicious applications and how to fingerprint compilers. And if you look at the source code, it's really easy to add your own signatures to that. I would love if you added those back for the community. But again, you can basically, script out a lot of things where you might say, okay, if I detect this, then run this. And that's a good way to start automating some things. I also have a presentation called Android Hacker Protection Level 0. It was actually how we went step by step through, I think, about 5 protectors. And we basically showed how you can unpack those and how you can defeat them. And there's also a tools repo that is the second to last link on this page. And that one has a few automated tools that we actually wrote as proof of concepts for unpacking things and unpacking them fast. There's also some interesting GDB scripts in there that pretty much anyone can modify 1 or 2 lines, and you'll be unpacking a lot of these protections, and it's fairly simple to automate. So good luck hunting. Thank you, BugCrowd, for having me. Again, you can follow me at Tim Strazzere on Twitter. And these are a bunch of other people who are good to follow. All the other speakers are good people to follow. And you'll see them usually tweeting out like interesting little tidbits or potentially blog posts that outline things. And doing research in your off hours is really going to pay off in your bug bounty skills. And hopefully you guys can, if you're interested in doing it this way, you don't have to. But if you treat it like a competition and you set a goal, you actually will be able to see measurable difference in your skill set. And this is a great way to just keep getting better and keep challenging yourself. You can basically treat it as like a Mario Kart ghost run where you want to do better than the previous time that you went at that competition. So again, thank you. And does anyone have any questions?
Awesome. Let's see, we have a question from Alex who asks, any tool to find hard-coded API keys, passwords, etc.?
So I believe there are a few tools, but I guess I would personally, if I were to look for hard-coded API keys, I would just unzip it. I'd run Boxmali on it, and then I would just do a recursive grep looking for API or API keys, or potentially grep for const-string, and that will tell you all the strings that are being loaded into a file. I'm sure there's some dynamic tools that also would help you try and find this out.
We also had someone, let's see, a huge thanks and respect. Someone just posted. Alex asked, what's the name of the cartoon that you're using for all the GIFs?
Almost all the GIFs were from regular show. There's 7 seasons and 2 movies, and you should watch them all.
Cool. Do we have any other questions from the crowd here? Casey just said high five for the Mario Kart Ghost Run reference.
Yep. And I will also share these slides hopefully shortly, and I will get them over to Sam as well. And I'm sure you'll share them somehow as well.
Yeah, we'll post them as well along with the video.
Perfect.
Well, I think that is it. Well, let me check what is up next on our schedule here. I think we've got a little bit of time until, yeah, we've got about 10 minutes until Abijeth starts. So that gives everyone about 10 minutes to stretch, get something to drink, use the restroom, do all that good stuff. But yeah, thank you so much, Tim. Everyone give Tim a round of applause in the chat. And yeah, thank you, Tim, for your time. I appreciate it.
No problemo. Thanks, guys, for having me.
Thank you.